we go back to lesson 2, we spent the entire lesson talking about segments. Today we're going to take some of those segments and lines and we're going to start putting them together to form these things called angles. Intense, right? Part of a line that starts at an endpoint and extends infinitely in one direction. We bring in a new topic today. It's called a ray. Beginning point. It's going to go through a point so that we can indicate the direction, but then it's going to go on forever through that point. A ray. Part of a line that starts at an endpoint and it extends infinitely in a direction. When we take these two rays and we connect them together, by that common endpoint, we create an angle. Ray number 1, ray number 2. Common endpoints, and we know the definition of an angle by now. The common endpoint of the sides of an angle, this location right here is what they're referring to. That's called the vertex. Vertex is just a special name for what we give to an angle. If we get into polygons later on, when we do, they use that term a lot to identify the number of vertices, which is the plural form of vertex. So for example number 1, just going to begin by identifying rays and all these parts, just like we did for lessons 1 and 2. We want to name 2 rays. When we name rays, understand we always have to start with our beginning point and where we're going to. Ray symbol, simply a line without the second arrow. Again, S indicates where we start, P indicates where we go through. Notice this is not the same as this. We cannot write it that way. It was okay for us to say that line PS is equal to SP because it represented the same line. Rays, we got to be a little bit more specific. We got to identify where it starts and where it's going through. There's the first one, second one if we wanted to, SQ. Also, don't really start with the beginning point that it goes through. 2 angles. When we identify an angle, there's a couple different ways you can go about it. If they give you the angle, which is typically a number, you can say that number. You can say angle 1. That's perfectly fine. But let's say they didn't give us this 2 here. The other way that you can write angles is with the points that form that angle. Q, S, R. The point at the vertex, which is the S, that has to be the middle letter. It would not be appropriate to say angle QRS unless they had that angle right there. Postulate 3, let's go ahead and open up our books. Page 14. I would not copy all of it down, but instead I would copy number 1 as well as number 2 and include the diagram over to the right. And it seems redundant, but again, later on we'll get in these things called proofs where you may have to come back to postulate 3. Basically, it's stating how to use a protractor, which we all know. Not gonna work now. Postulate 3. Given a point x on PR, consider rays xp and xr, as well as all the other rays that can be drawn with the x as an endpoint. On one side of PR, these rays can be paired with real numbers from 0 to 180, such that xp is paired with 0 and xr is paired with 180. And then secondly, if xa is paired with a number c and bx is paired with a number d, then the measure of axb is the difference between c and b. Again, how to use a protractor 101. Seems very basic, and it is. Don't overthink it. Acute angle, we all know, that's an angle that's less than 90 degrees. Next one is a right angle, which measures exactly 90 degrees. Something greater than 90 but less than 180 is going to be considered to be obtuse. And we actually have a fourth angle that we don't use a lot, but in geometry it is there. It's called the straight angle, which is exactly 180 degrees. Now a lot of us would probably just call it a line, but just know we can call it a straight angle if we want to. Acute, right, obtuse, and straight. Next is postulate 4. That one is also in your book. The angle addition postulate. At the beginning of postulate 4, they state if D is interior of the angle ABC. Basically what they're saying is you have angle ABC, and somewhere inside of that angle lies point B. So basically what they're saying is now you have created another angle within here. You actually created two of them. So it's kind of like the same definition of betweenness. You know, if C is between A and B, there's A and B. Somewhere in there is C. Same idea with angles. Point D is interior of the angle, so it's somewhere in between there. And you've been using this idea a lot already, going back to your junior high days. If we have two angles that share this common side, which is BD, we know that the sum of these two angles will equal the overall angle, and that is the angle addition postulate. As long as they share that common side, we can add those two together to get the overall. Example number 3 is a pretty basic example of using that postulate. Number 4. Measure of angle RST is equal to 22 degrees. Measure of TSU is 69. We want to find the measure of RSU. Also classify the angle. In geometry, they're really good at throwing multiple questions at you within the same question, so make sure you identify all the parts. Let's go ahead and start with finding this measure. RST is 22 degrees. Now, with your book, you don't have the liberty of writing in the angles, okay? So if you'd like to copy it down to include the angle so that it's easier to see, that's fine. TSU, that's 69 degrees. We want to know RSU. Tracing the angle that you want may be helpful. So obviously, if I want to find that angle in red, angle postulate tells us we can add those two together. 22 and 69 will get us a total of 91. Which means we're looking at what type of an angle? Basic. Diagrams will get a little bit more difficult as we move on, but the next thing we need to talk about is what it means to bisect something. Bi means two parts, and if we want to bisect them, we're going to divide them equally. So if I have an angle, I'm going to create two congruent triangles off of that angle that's been given to me. Divide into two congruent parts. If you and your friend are sharing your Snickers bar, you're going to cut it right down the middle so that you can share it, or you're going to cut it a little bit more so it favors you, but bisect is when you're going to remain equal. The measure of ABC is 44, BC is angle BD, ABD. Measure of EBF is 23. I want you to find the measure of angle CBE. On your own, go ahead and fill in the pieces. Without then looking in your book, share with a partner. Or work with a partner if you need to. Share with the neighbor once you have your answer. Everybody have an answer? Let's go to Hallie and Liz. 67. Let's go to the other side. Maya, Miles, and Kendra. 67. Anybody else? Yeah, if we look at angle ABC, that's 44. That was given to us. The next statement indicates that BC is going to bisect this ABD. So what's this angle here? 44. Very good. It's the same. So we have 44 and 44. EBF. So EBF is 23 degrees. And what do these mean again? They're the same. They're congruent. So this is 23 as well. And again, tracing can be helpful if you need to. C, B, E. Yeah, looks like we need to add those two together. $67 degrees. Lesson practice problems B, C, and D.